In this problem, we are asked to find the phasor based on cosine transform for each of the trigonometric functions. First we have a, then we are given b, c, and lastly we will solve for d down here. First we're going to start solving for a, and we can see that we have our Vmax as 170 and our angle as a -40. So when we write this out, we know we have 170 with an angle of -40 degrees. Well, that's going to be the answer for part A, 170 and -40. We have our magnitude, which is the maximum voltage, and our angle, which is the negative degree. For part B, it's going to be somewhat the same, slightly different, but we can see that we have a sine right here. We know that cosine lags behind sine by about 90 degrees. And we can see that. I'll draw a graph right here. If we graph sine, it starts at 0, and there's a peak right here, and it goes like this, while our cosine starts at this peak, and then dips, and then goes from here. The cosine peaks right here, sine peaks right here, so our cosine is about 90 degrees behind our sine, which is again why we need to subtract 90 degrees from this given angle. So to make it a cosine, we are going to have a -90 degrees, and to this we are going to add the angle for our sine, which is 20 degrees. And this is going to give us a -70 degrees. Our magnitude, the 10, is going to be the same, so we could just plug this in here, and we're going to have a 10 angle -70 degrees. That will be the answer for our part B. Now we are going to move on to our part C. In part C, we have two separate functions, so we need to add them together. To add them together, we are first going to write them out. They are both in cosine, so we don't need to convert them from sine to cosine. We have a 5 as our Vmax for the first equation. Then our angle is 36.87 degrees. And then our second equation has a 10 with an angle of -53.13 degrees. From here, we need to add them together. However, we cannot add them together since they are in polar form. We need to convert them to a rectangular form and then add like terms. To convert from polar to rectangular, we can use this equation, where we have the number out front, a parenthesis, multiplied by the cosine of our angle, plus j times the sine of our angle, with a closing parenthesis. And these are the values that we will be getting. Now from here, we are going to combine like terms, and this is going to give us a 10 minus a j5. Now this is our rectangular form. Our question wants us to convert it back into the polar form, that way we have our magnitude and our angle. And to convert from rectangular to polar, we are going to note that we have our Vmax equal to the square root of our real number squared plus our imaginary number squared. And then our angle is going to be equal to the tangent -1 with our I divided by our regular number. And our I, again, is just the imaginary number. So we're going to plug both of these in here, and then we have to graph it to make sure that our angle is in the correct quadrant. From here, I'm going to get that our Vmax is equal to 11, and our angle is -27. If we graph our rectangular equation for this, we know that our real number is going to be in our x-axis, and our imaginary number is in the y-axis. So our real number is a positive, it'll be here, and our imaginary number is negative, so it's going to be here. That means our angle has to be in this quadrant. Since our angle is a -27, it checks out, and now we can finally say that our answer is approximately 11.2 for magnitude, and then -26, once we use these formulas right here and convert it into the polar form. Lastly, we are going to look at part D. In part D, we have two different expressions just as we had previously. However, we have a sine right here, and we need to convert this to cosine. To convert from sine to cosine, remember cosine is 90 degrees behind our sine, so we are going to have a 30 degrees minus the 90 degrees, and this is going to give us 60 degrees if we were to put this in the cosine form. Now from here, we are going to rewrite these, and these are the polar form for our two functions. Now we need to convert them to a rectangular form like we did up here using this equation, and then we can add together the like terms. Also, I made a mistake right here. It is 30 minus 90, so that will give us a -60 and not just 60. So there should be a -60 here, super important to have that in. And these are going to be the approximate values that we get. Now we can add together the like terms. And for this, we're going to get approximately 162 plus j times 299. This will be the equation for our two functions. If we graph this, we know that our imaginary number is in the positive and our real number is in the positive as well, so our angle is going to have to be somewhere in this quadrant, otherwise we will add 180 degrees to it. So now we have to convert this rectangular form back into the polar form using these equations up here. From this, we're going to get approximately 340 for our magnitude and approximately 62 degrees for our angle. We can see that our angle is positive, so it's going to be in the first quadrant, and that checks out good. And that is how you would go about solving this problem. If you want more network analysis problems or notes that go over the entire coursework, they are linked in the description below the like button.